Hello dear students, in this video we will be learning about simple lifting machines. This is unit 6 of your engineering mechanics. Course outcome we are trying to achieve here is, after learning this you will be able to select the eco-friendly relevant machine for given purposes. Prerequisites are concepts of force, displacement and friction. So I am assuming that you are familiar with these concepts and we will move ahead with simple machines. So, what is a simple machine? It is a device in which effort is applied at one place and work is done at some other place. It is done manually. We do not provide any electric power to this machine, right? So, simple machine is in which you apply effort at one place and work is done at some other place. Examples of the same are pulley, bicycle, sewing machine, and simple screw jack, right? Next is compound machine. A machine consisting of many simple machines is called compound machine. It is run by electric or mechanical power. Examples for compound machines are scooter, crane, grinding machine, and lathe machine. And then there are lifting machines, a device in which heavy load can be lifted by less effort, right? You are lifting a very heavy load by putting very less effort. So these are your lifting machines. Examples are simple pulley, simple screw jack, lift, and crane. So these are some simple but important definitions. Next, we will learn some technical terms related to simple machines. So, first one is mechanical advantage. It is the ratio of load lifted, that is W, and effort required, that is P. So, mechanical advantage MA is W by P, where your W is the load lifted by the machine and P is effort put in by you, right? So, mechanical advantage is W by P. Next is velocity ratio. The ratio of distance moved by effort, that is y, and distance moved by load, that is x. We will call it VR, velocity ratio, that is y by x. So whenever there is some work done, your load or effort or force will move some distance. So these are the distances moved by the effort and load. Distance moved by effort is denoted by y, distance moved by load is denoted by x, and velocity ratio is y by x. Right. Then there is input. Input is P into Y. That is work done by the effort or work done on the machine. Whatever work we do on the machine is input. That is the effort put by us and distance traveled by that effort. So P into Y is your input. Similarly, output is work done by load or work done by the machine. So machine has lifted W load and that load W has traveled X distance. So output is W into X. So input is P into Y, output is W into X. Next is efficiency. Now the ratio of work done by the machine and work done on the machine, right? Again, work done by the machine, that is your output, and work done on the machine by you, that is your input. So eta, efficiency will be denoted by eta. So this eta will be output by input into 100%. Now let us understand this efficiency in some other terms. So we know that output is W into X, right? So eta is W into X by input is P into Y. So W into X by P into Y into 100%. Now rearrange this, we get W by P in numerator and Y by X is X in denominator. So W by P by Y by X into 100%. Now this W by P is your mechanical advantage and Y by X is your velocity ratio. So efficiency can also be written in these terms, that is mechanical advantage by velocity ratio into 100%. Now notice that we will always write efficiency in percentage terms. So whatever decimal value you get, you will multiply it with 100 and show the percentage sign. So that is your efficiency, output by input or MA by VR. Next is ideal machine. A machine having 100% efficiency is called ideal machine. Now in ideal machine, friction is zero, output is equal to input, and mechanical advantage is equal to velocity ratio. Now we can clearly see from formula here that if efficiency eta has to be 100%, output should be equal to input, so this will become 1. So output is input. Similarly here, ma should be equal to vr, so this becomes 1 and efficiency becomes 100%. So for ideal machine, there are these conditions that efficiency should be 100%, friction is 0, output is equal to input, and ma is equal to vr. This is your ideal machine. Next, let's see effort lost in friction, that is PF. Effort required to overcome the friction between various parts of a machine. Right? Effort required to overcome the friction between various parts of a machine. We have learned friction in Unit 5. You understand that between any two surfaces, there is some friction. So, in moving parts, first you will need to overcome this friction, then your machine will work. Right? So, this effort lost in overcoming this friction is called effort lost in friction. Now consider that P is total effort put in by you, P0 is effort required for ideal machine, and PF is effort lost in friction. So the relation you get between these three terms are PF, that is effort lost in friction, is equal to P minus P0, that is effort required in our machine minus effort required in ideal machine. Now, in ideal machine, there won't be any friction, so you will require much less effort, and this difference is effort lost in friction. Next, let's understand same thing in terms of load, right? So that will be called friction load, WF. Total friction force produced when machine is in motion is called friction loss, WF. Now consider that W is the load lifted by our machine. W0 is load lifted by ideal machine, and WF is friction load. Now the relation between these three will be WF, that is your friction load, will be W0 minus W. Right? This is reversing here. Notice this is P minus P0, that is this is W0 minus WY, because your ideal machine will lift more load. Because it has no friction, it will be lifting more load. So W0 will be bigger value, W is your smaller value. So friction load will be W0 minus W, that is your friction load. Next thing is reversible machine. Now, if a machine is capable of doing some work in reverse condition after the effort is removed, it is called reversible machine. Right? Machine is capable of doing some work in reverse direction. Now, as far as you are applying the effort, machine is moving, it is working. Right? As and when you remove this effort, right, there will be two scenarios. Either the machine is working in reverse direction or it stops. So if it works in the reverse direction, then it is called reversible machine. Okay, next, opposite to this is non-reversible machine. If a machine is not capable of doing some work in reverse direction after the effort is removed, it is called non-reversible machine, or it is also called as self-locking machine, because the machine locks as you remove the effort. Now there is a condition for reversibility. So for the machine to reverse, output should be greater than machine friction, right? Or your machine will be stopped by the friction only. So if output is greater than machine friction, the machine can work in reverse direction. Now let us consider this in formula terms. So we know that output is W into X. Machine friction is simply your input minus output. Input is P into Y, output is W into X. Now take this Wx on the other side, you will get 2Wx is greater than P into Y. So we get Wx by Py is greater than 1 by 2. Now this Wx is your output, Py is your input. So this is nothing but eta, efficiency. So if efficiency is greater than 50%, if efficiency eta is greater than 50%, your machine can reverse, or if it's not, it is non-reversible or self-locking machine. Right? Next is law of machine. The law of a machine gives the relationship between the effort applied and the load lifted. Okay, means the relation between P and W is law of machine. For any machine, if a graph is plotted between effort P and load lifted W, it will be found that it follows a straight line relationship. Right? So there is a simple graph here. And on y-axis we have effort P, and on x-axis we have load W, right? So the equation for this line will be P is equal to mw plus C, right? P is equal to mw plus C, similar to y is equal to mx plus C. Now here m is the slope of this line, which will be your coefficient of friction, and C is the initial friction that we need to overcome before any load is lifted, right? So consider here that after the effort value C, your load will start lifting. Till then, the effort is being lost in overcoming the friction. So this is law of machine, P is equal to mw plus C. Then two more important formulas are maximum mechanical advantage and maximum efficiency. So let us see that. We know that mechanical advantage is W by P. So we will write it in the law of machine form. So we know that P is equal to mw plus C. So I'm replacing P by mw plus C. So you get Ma is W by mw plus C. Now divide this with W. Divide the whole equation with W. In numerator you get 1, and in denominator you get m plus C by W. 1 divided by n plus C by W. Now the value of this C by W will be very less, because C is your effort lost in friction, which should be really small, and W is the total load lifted, which will be a bigger value. So C by W is a very small value, negligible value. We will neglect that, and we will write maximum mechanical advantage Ma max is equal to 1 upon m. Now this is important formula to remember. Ma max is equal to 1 upon m, where m is the slope of that line, P versus W line, or coefficient of friction. Now from this we get maximum efficiency. We know that efficiency is Ma by Vr. So eta max is Ma max by Vr. And from above we know that Ma max is 1 upon m. So eta max, maximum efficiency, is 1 divided by m into Vr. Right, now there are some simple lifting machines which are in your syllabus. What you need to do is you need to practice the sketches of all these. Right, you may be asked in GTU examination to draw a sketch of simple wheel and axle or simple screw jack, etc. And also you need to remember velocity ratio equations for all these machines. So here we will quickly see them so that we can use these equations in solving further examples. So first one is simple wheel and axle. Now you can see that we are applying the effort P on the wheel, and load W is lifted by the rotation of the axle. We get velocity ratio as capital D, that is diameter of this wheel, and small d, that is diameter of this axle. So this is your simple wheel and axle, and velocity ratio formula for the same. Again, you need to practice drawing the sketches of all these machines and remember the velocity ratio. Here I am going quickly through all these machines, just showing you the velocity ratios. Next is simple wheel and differential axle. So the difference here is there are two different size axle, right? Axle B and axle A. So the formula for VR is 2 into capital D, that is diameter of wheel, divided by D1 minus D2. These are your diameters of axle. Worm and worm wheel, again effort is put in this wheel and load is lifted by this drum. Velocity ratio is RT by small nr. Next is single purchase grab. Here velocity ratio is L by R into T1 by T2. Right, T1 and T2 are the number of threads on this pinion and spur wheel. Right. Next, double purchase grab. VR is L by R into T1 by T2 into T3 by T4. Next is simple screw jack, where velocity ratio is 2 pi L divided by P. P is pitch of the screws. Right? P is pitch here. So now let us consider some examples. Example 1, a law of machine for simple machine is P is equal to 0.2 W plus 4. Find out effort required to lift load of 100 kilonewton. Also calculate maximum mechanical advantage and maximum efficiency if velocity ratio is 40. So this is our question. What is given is the law of machine is given. Load to be lifted is 100 kilonewton. Velocity ratio is 40. You need to find out first effort required to lift this 100 kilonewton, then maximum mechanical advantage and maximum efficiency. So first we will start with this law of machine. P is equal to 0.2 plus W. Now what is the load you need to find effort for this? 100. So we will put W is equal to 100 here. So when W is equal to 100 kilonewton, P is 0.2 into 100 plus 4. So we get effort required 24 kilonewton. That means 24 kilonewton effort will lift a load of 100 kilonewton in this machine. Again, from law of machine, we know that P is equal to mW plus C. Now comparing these two, you get m is equal to 0.2, right? We are comparing this law of machine and the ideal law of machine. So m is equal to 0.2 and c is equal to 4. So you are getting value of m and c both. Now we know that maximum mechanical advantage is 1 upon m, that is 1 upon 0.2, that is 5, and maximum eta, that is maximum efficiency, is 1 upon m into VR. VR is given as 40. So 1 divided by 0.2 into 40, you get it as 0.125, but we show this efficiency in percentage terms. So we will write it as 12.5 percentage. Example number 2. In a lifting machine, an effort of 2 kilonewton raised a load of 60 kilonewton and an effort of 3 kilonewton raised a load of 100 kilonewton. The velocity ratio of machine is 50. Right. So what is given here is, you are not given the law of machine, you are given two cases. That says that when effort P is 2, load W is 60, and when effort P is 3, load W is 100 and velocity ratio is 50. You are asked to calculate first effort required to lift a load of 160 kilonewton. So what will be P when W is 160? Next, maximum efficiency of machine, that is eta max. And third one is state the machine is reversible or self-locking, right? These are the three questions. So what we need to do is, first we need to derive the law of machine. The law of machine is not given here. We need to derive that. We will do it with help of these two cases. So we know that P1 is 2 kilonewton, W1 is 60 kilonewton, P2 is 3 kilonewton, W2 is 100 kilonewton. Now law of machine P is mW plus C. Now I'm putting these four values as two equations here. So for first equation, you will get when P is 3, W is 100, right? When P is 3, W is 100. So first is 3 is equal to M into 100 plus C. That is your equation 1. In second case, when P is 2, W is 60. So 2 is equal to M into 60 plus C. That is your equation 2. Now subtracting equation 2 from equation 1, we get 3 minus 2 here 1. 100m minus 60m, here we get 40m, and c minus c gets cancelled out. So you get 1 is equal to 40m, that means m is equal to 0.025. We got the slope of the line, m is equal to 0.025. Now I will put this m in any of these equations, right? So putting value of m in equation 1, value of m in equation 1, right? So put m is equal to 0.025 here. You will get c is equal to 0.5. Okay, I am putting this value of m 0.025 here. So you will get c as 0.5. So law of machine in this case becomes P is equal to 0.025 W plus 0.5. M is 0.025 and C is 0.5. So P is equal to MW plus C. P is equal to 0.025 W plus 0.5. Now, once we have derived this law of machine, we can answer all these three questions. First question is effort required to lift a load of 160 kilonewton. So simply put W as 160 here. W as 160, and you get effort as 4.5 kilonewton. Next question is maximum efficiency of the machine. We know the equation for eta max, that is 1 upon m plus m into Vr. So 1 upon 0.025, that is m into Vr, that is 50. So we get it as 0.8, but we need it in percentage, so it is 80%. And third question was state whether your machine is reversible or self-locking. So since eta max is 80%, which is greater than 50%, machine is reversible. Right? We know the condition for reversibility is if efficiency is greater than 50%, machine is reversible. So in this case, our machine is reversible as efficiency is 80%. Move ahead to example number 3. A weight of 450 Newton is to be raised by means of wheel and axle. The axle is 100 mm in diameter and the wheel is 50 mm in diameter. If a force of 120 Newton has to be applied to the wheel, find mechanical advantage, velocity ratio, and efficiency. Right, this is very simple example, but it was asked in 7 marks in GTO exam. Okay, for 7 marks. Now here, weight is given simply, W is 450. If a force of 120 Newton has to be applied, means this is our effort. 120 Newton effort lifted 450 Newton load. So this is W, this is P. So MA, mechanical advantage, can be simply calculated by W by P, that is 450 by 120, 3.75. Next, we know that for simple wheel and axle, your formula for velocity ratio is diameter of wheel by diameter of axle, that is 500 by 100. Okay, diameter of wheel is 500, diameter of axle is 100. So 500 by 100, that is 5. So velocity ratio is 5. Eta is simply MA by VR. MA we get as 3.75. VR is 5. So eta efficiency is 0.75, that is 75 percentage. So three values were asked, we calculated all three. Now example number 4. In a double purchase grab, the pinions have 20 and 30 teeth and spur wheel have 80 and 90 teeth. So these teeth values are your T1, T2, T3 and T4. Right? The handle is 30 centimeter long and load axle is 20 centimeter in diameter. Find effort required to lift a load of 2000 Newton when efficiency is 50%. So first we will need to calculate the VR. For that, data given is, so your teeth in the spur wheel are 80 and 90. Those are your T1 and T3 value. So T1 is 80, T3 is 90. And teeth in pinions, that is 20 and 30, these are T2 and T3 values. So T2 is 20 and T4 is 30. L, right, length of the handle, that is 30 centimeter, and uh, radius of the axle, the load axle is d by 2, that is 20 by 2, 10 centimeter, and formula for velocity ratio is L by R into T1 by T2 into T3 by T4. Now putting all these 6 values here, so L is 30, R is 10, T1 80, T2 20, T3 is 90 and T4 is 30. You get velocity ratio as 36. Then efficiency eta. Eta is MA by VR. So if we need MA will be eta into VR. VR will be in multiplication on the other side. So mechanical advantage is efficiency into velocity ratio. Efficiency is given 50%, but we will calculate here in decimal terms. So we write it as 0.5. So MA is 0.5 into 36, mechanical advantage is 18. Now mechanical advantage is W by P. So P is equal to W by MA. And what is the load for which we need to calculate effort? Load is 2000 Newton. So W is 2000, MA is 18. We get effort required to lift this 2000 Newton load is 111.11 Newton. Okay, so these examples are very simple once you remember all the formulas. What formulas are required to calculate this? First, you need to know velocity ratios of all simple machines. Okay, six machines are listed in your syllabus, so you need to know the velocity ratios of all these. Then formula for output, for input, efficiency, mechanical advantage, velocity ratio, maximum mechanical advantage, maximum efficiency. Very simple short formulas for everything, and you will be able to calculate the examples very easily. I hope this helps. Thank you for paying attention.